And we are live. That means the rest of you are going to be quiet now, so we can hear ourselves think. Anywho, so we're doing real zeros of polynomials. Another word for zeros is roots. So this is the rational zeros theorem. It's also oftentimes called rational root theorem. And what you do with the rational zeros theorem is it's basically what we call an existence theorem. It tells you that something exists, but it doesn't necessarily tell you all of like that it actually is the zero that you want. So that might have sounded kind of weird, but this is what's going to happen. We know from previous lesson that the number of roots that the function can have is equal to the degree or one less. So if you have x squared, at most you can have 2 zeros. Okay? Doesn't mean you're going to have 2 zeros, but at most you can have 2 zeros or 2 x-intercepts, right? For x cubed, you can have 3. At most 3, right? It has to be equal to the degree. All right? So, what this theorem is going to tell us is going to help us find those zeros. But I have to be like cautionary with you. We did this in Algebra 2, and it was annoying then. It might be annoying now. Okay? It tells us, it produces a list. That's what it does. It produces a list of possible zeros. And that list does not mean that every single one is going to be a zero. But if there is a rational zero, it's going to be in that list. Okay? So to say that again, we're going to generate a list with this theorem. And the rational zeros that exist for this function have to be in that list. But that doesn't mean that it's all the zeros. Are we clear?
Clear.
Okay. So we're going to start with an example. That's the easiest thing to do. I'm going to go with example 1 here and hope that it'll make sense. So in example 1, we have p of x equals x cubed minus 3x plus 2. Alrighty? So, according to the rational root theorem, I am going to take a ratio of p over q. P represents the factors of the constant term, which in this case are 2. The factors of 2 are 1 and 2. Because it's a prime number, right? Only divisible by 1 in itself. On the bottom, you want the factors of the leading term, which in this case is 1. Right? So this is a really simple question. We're going to go to a more complicated one in a second. But what you do is you find the ratio of p over q. So 1 over 1 and 2 over 1, which in this case is just 1 and 2. It's not always going to be that easy. Okay? So what we know with this list is that if this polynomial has rational zeros, it has to be one of these two numbers. It can't be 3. It can't be 1/2. It has to be one of these two numbers. Are we clear? But it's not telling us the ones that aren't rational. You guys remember what a rational number is? A rational number is a number that can be written as a fraction. So like the square root of 2 wouldn't count, but 1/2 would count, and integers would count. So any fractions or integers that are zeros have to be in this list. So then how do I know if 1 is a 0 or if 2 is a 0? We use synthetic division. We're actually using the remainder theorem from yesterday, or from the last lesson, to put this all together. So what we're going to do is we're going to put 1x cubed, 0x squared, negative 3x, and then the 2. And we're going to start by dividing by, I'm just going to go ahead and pick the 1 here. Start somewhere, right? If 1 is a 0, what should happen when I do this division? I should get a 0 remainder, right? So I'm going to try that. 1 times 1 is 1. Add those together, you get 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. That's negative 2. Yay! It's a 0. So this one works. You can try the 2 as well. In a second, it'll become more clear why that doesn't make any sense to try to, but we'll see how it goes. So 2 times 1 is 0 plus 2 is 2 times 2 is 4. 4 minus 3 is.
It almost works.
So is that a 0 remainder?
Nope.
No. But I could have told you that wasn't going to work. And I'll tell you why right now. Because this polynomial can have at most 3 zeros because it has a 3rd degree. So the fact that I only had 2 numbers to pick from, only one of them can work because if it's not rational, then what will it be? Irrational. And irrational roots are always going to come in pairs, like 2 at a time. So since this has 3 zeros, if 2 of them were rational, like if they both worked, if both of those are rational, it means that I have 1 left, and it would have to be irrational, but you can't have 1 irrational 0. They always come in pairs. You see how that works? So I knew when I generated my list that only one of these numbers could work, because that would leave me with 2 irrational zeros, which would be in a pair, or they could be imaginary. Imaginary zeros also come in pairs. We learned that also in Algebra 2, and we'll visit it again in this section as well. But just to remind you that that's how that works. So, at this point we know that x equals 1 is a 0. So to answer the question, find the rational zeros, I am done. I found the rational 0 and it was the 1. Alrighty, so any other preguntas here? Alrighty, so let's try to go to another one that's more complicated. Because that actually seemed not that hard. It wasn't very daunting. What sucks is sometimes you actually get a P over Q that has like a gazillion options. And I'm really sorry, but that's just what happens. So we're going to use the calculator to help us do that kind of stuff. So I want to find one that has a larger list. So we're going to go with example 2. And I probably won't be able to finish all of this lesson today. So hopefully our basketball players will be back on Monday, and then we can go over the rest of it. But we're going to do this again with another example. This time we want P of x equals, does anyone have their book open? They can just tell me what it is because it's faster.
2x to the 3rd power plus x to the 2nd power minus 13x plus 6.
Okay, so in this case, because 6 is not a prime number, our list is going to be a lot longer than it was in the first example. And now that I'm doing that, I'm thinking that I already made a mistake in the first example, not a huge one, because the possible solutions should have been plus or minus. You can have negative factors too. So, sorry about that, but here's P, here's Q, and we're going to say 6 and 2. So for the 2, your factors are going to be plus or minus 1 and plus or minus 2. Because you could also get a positive 1, or sorry, a positive 2 by going negative 1 times negative 2 is positive 2. So we have to include the negative options as well. For 6, you're going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Right? Right. So now my list is going to be a little bit longer. Because now you have to go and create the ratio. So 1 divided by 1. You're going to have 1 divided by 2. You're going to have 2 divided by 1. 2 divided by 2, which is 1. It's already there. 3 divided by 1. 3 divided by 2.
And negatives.
And then 6 divided by 1. And then 6 divided by 2, which is 3, but it's already in your list. So now we have 2, 4, 6, 8, 10, 12 possible rational zeros. And for us to do synthetic division 12 times until we find the right one is going to be kind of annoying. So at this point, I need you guys to join me with your calculators. And what we're going to do is we're going to use that remainder theorem because we know that equivalent to synthetic division is plugging in the number, right? And what should happen when I plug in the value? I should get 0.
Literally do.
Okay?
Okay.
So we're going to now try to find it that way. So I'm going to type in my y equals this equation up here. So we're going to do, ooh, someone was playing with my calculator. It's all weird. Okay, there we go. So we're going to type in 2x cubed and then plus x squared. And I hope that David gave me the right equation and I'm not doing all this work for nothing. Minus 13x plus 6. And then we're going to fix our window. I will say that right now in the video, and I'll tell you all that you have to make sure that plus or minus 6 is part of your window. Okay, so for example, for whatever reason, my calculator right now says that the x-min is -1/2. So -6 won't even appear. So I would suggest that you always check your window and put it at standard. So you do that by hitting the zoom button. And then option 6 will give you a standard viewing window. And then we're going to do the second trace feature. And then, are you guys there with me?
Mhm.
Yeah? So option 1 is value. And then on the bottom left-hand corner of your screen, it should be blinking x equals, right? And we're just going to start typing them in. -1 is 18. Does that mean that it's a 0?
No.
No. So +1, I'm getting -4. So these don't work. 1/2, I got 0.
Yeah.
Lovely. So what I want you to do, alrighty, what I want you to do is, once you find one of them, your goal is going to be to get your function to the point where it's a quadratic. Why do you suppose we want a quadratic?
Factor finds.
What did I say earlier about the zeros that come in pairs?
Rational.
They're irrational, and you know where the irrational comes from? Quadratic formula. X equals -b plus or minus radical. Okay? So
That is immortalized on video.
it is pretty important, okay? So what I want you to do is, I don't want you to be lazy, Ben, and then sit there and keep putting all these in until you find all 3 of them. It is possible that you can find all 3 of them by just plugging into the calculator. That's not what I'm after. I want you to find enough so that you can reduce your function to a quadratic. That means that if you had x to the 5th power, you would have to find 3 zeros before it could be a quadratic, right? You can't plug in x to the 4th into the quadratic formula.
True.
Does that make sense, why I'm doing that?
Oh, I see.
Do you see what I'm saying? So you want to keep finding them, but at some point you do have to do some math, okay? So, and not let the calculator do everything. So I found one, that's enough for me. Now I go to division. Because I know it's going to work. Because I did my list and it worked, right? So I know it's going to work, but I'm going to get my quadratic. So I'm going to have here 2x cubed, 1x squared, -13, and 6. So 2 times 1/2 is,
1,
1 plus 1 is,
2,
2 times 1/2 is,
1,
-13 plus 1,
-12.
-12 times 1/2 is, bam.
Oh, yeah.
Okay?
Man, just keep going.
But now these are the coefficients of a quadratic. It's 2x squared plus 2x minus 12. I can factor this. First of all, they're all divisible by 2. So I'm probably going to take the 2 out. Right? And I can factor this with our old previous methods. We can put x. 3 times 2 is 6. And then you're going to want 3 minus 2. Right? Because you want -6. And a positive 1 here. So we're going to have 2 times x plus 3 times x minus 2. Right? So what are my zeros now? If I equal that to 0, I'm going to get -3 positive 2, and don't forget the 1/2.
Yeah.
So that my final answer will be all 3 of those, which makes sense because it's a cubic. It's supposed to have 3 zeros. And in this case, all 3 zeros were rational, which means that if I was lazy, and if I allowed you to do it, you could have found the -3 and the 2 because they were in my list. I just hadn't gotten to them yet. Right? But beware that it will find you'll find all 3 zeros in your list if they're rational, but not if they're irrational. And my next example, and probably my last because I'm looking at the clock, is going to be one where they're not going to be all in the list. And I want you to kind of see how that's going to work out. So we're going to go to example 3 now. Let me know when I can, how are we doing on time over there?
It's 15 minutes.
Okay,
Not bad.
not bad. Can I change the screen?
Yes.
Example 3 has p of x equals x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10. Okay? So now it says find the zeros of p. It wants me to find them all. All right? So here we go.
Oh my gosh.
I know, right? The bigger those numbers get, the more factors they have. It's kind of annoying.
Well, okay.
But here we go. This is why I'm allowing you to use your calculator for some parts. Okay, but not for everything. Don't get crazy. You're like, why not? I want to be crazy. Okay. So P is 10 and Q is 1. So we're going to go with plus or minus 1, plus or minus 2, plus or minus 3. No plus or minus 3. Oh my goodness, people. Plus or minus 5, right?
Who said 3? Me.
I did, but I thought you guys were going to catch it, but you didn't. 1, 2, 5, 10.
Yes.
The good news is that the Q value is only a 1. So you divide all that by 1 and you're going to get the same exact thing. So this is my list. 2, 4, 6, 8 options. 8 options. All right? So we're going to first and foremost type this little baby into this little baby. Sorry, I just had a baby, so it's kind of like
Yeah.
x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10. Graph, graph. So I'm going to type in these values to see if I can find how many zeros do I want this time
4.
before I go to the synthetic division.
Oh, you
Two.
need 2. Oh, right.
I want 2. Okay?
Okay,
So
-2 and 5.
we're going to try 1, second trace, option 1, x equals 1, I get 24. No bueno. -1, I get -12. So it's not plus or minus 1. 2 is 12. -2 is 0. So done with those. 5. 5 is 0. Look at that. See how lucky we were? Okay. So now I have 2 zeros. I can stop looking, although a lot of you are still looking. That's cool. But we're done because we found 2 already. So now we're going to go to synthetic division again. Put a -2 there. A 1, -5, -5, 23, and 10. That's a funky looking 5. Let's see here. I think I did that right because I got a 0, so be kind of fast. Right? Time saver, okay? Remember, you want to reduce this to a quadratic. Thus far, I have reduced it to a cubic. This is a cubic. 1 degree less than the original, right? You might not have known this, but you can actually continue the synthetic division right there.
And bring it back. It's homework.
don't start all over again, because then you're just gonna have 2 cubics. Right, what's that?
No, I wasn't sure like how to simplify it even more.
Oh, you already started the homework. Ah, good for you. So then we'll have 5.
This is just like
You're just using these numbers now as your coefficients.
2x minus 1.
So this column is a 3rd degree, right? X cubed. This column is now x squared. So I'm going to get, but I can tell you this, x squared minus 2x minus 1 equals 0. You can't factor that. I mean, you can try.
The negatives don't work.
What you could do if you don't believe me is you can try the rest of these numbers.
They don't.
None of them are going to work because Ben already tried to do that. See, because he's lazy, he didn't want to do it by himself.
Yeah.
But that's what's happening. These are actually irrational. So only rational zeros will be in this list. It's not going to give you a list of root 2 or anything like that, okay? So the only thing that we have left to do now to find the remaining zeros, because there's still 2 more, right, is to use the quadratic formula. So we know that it's x equals negative b
Okay.
plus or minus radical
Can you just make it
b
equal?
squared minus 4ac all divided by 2a.
Oh my goodness.
All right,
Oh my
so basically that's my a, my b, and my c, right? So negative b is negative negative 2, b squared, ac, right? So we're good? So here you're going to get negative, and negative is positive 2. This is 4 minus negative plus 4. 4 plus 4 is 8. Yeah, in Spanish. I know I'm weird. Okay? 8 is the same thing as 2 root 2.
C. I do not believe it's quadratic.
C.
I'm sorry. I can't do it. It's not making me happy.
And since you have a 2 here and a 2 in front of the root, you can actually cancel all those 2's.
That's beautiful.
So do you get 0 plus 2 root 2?
No.
Yeah.
What do you get? No? I knew you were going to say that too. 2 divided by 2 is not 0. You just ignored it. Just because it cancels, something goes away, okay? It's a 1. So your answer is going to be over here. 1 plus or minus. And again, 2 divided by 2 is 1 root 2. So you now have 4 zeros, negative 2, 5, 1 plus root 2, and then 1 minus root 2. 4 zeros, right? So those are your 4. 2 of them are irrational because they come in pairs. And then you have your other 2 that are over here that are rational. So 2 irrational and 2 rational. Alrighty? Do you think we can do that? Okay, so on Monday, we're going to finish with a couple of other things, which is the Descartes rule of signs and the upper and lower bounds.
I need to write that.
But they're actually pretty easy, so it shouldn't be a hard thing to do. I want you guys to get started on the homework. You can turn that off now.